This is a video walkthrough for review for the Unit 1, which is an optional assignment. So in 1 through 2, a trig ratio is given and one side length for each right triangle. We're going to use the trig ratio to find the other side lengths. So what we know is that cosine of b is equal to the square root of 2 over 4. We know that cosine is the ratio of adjacent to hypotenuse. Cosine b's adjacent is 3, and the hypotenuse is c. So 3 over c must be equal to the square root of 2 over 4. If we want to solve this proportion, we can cross multiply. So c times the square root of 2 is equal to 3 times 4, which is 12. Dividing by the square root of 2, and then simplifying by rationalizing the denominator, that gives us a c value of 6 times the square root of 2. To find the remaining side, we can use the Pythagorean theorem. So one of our legs is 3, the other leg is unknown, and c is 6 times the square root of 2. So 3 squared is 9, and 6 times the square root of 2 squared is 36 times 2, or 72. Subtracting 9, that will give us 63. So b is the square root of 63, which is, in simplified form, we can factor a 9 here, so that would be 3 times the square root of 7. Question number 2 is a similar question. So tangent of angle Q is equal to 2 is given to us. And so if I look at angle Q, tangent is the ratio of opposite, which is 2 times the square root of 7, over adjacent, which is P. So we can multiply both sides here by P, and that will give us 2 times P is equal to 2 times the square root of 7, dividing by 2, P is the square root of 7. From here, since we now have 2 sides that we know, we can find the third side. So one of our legs is 2 times the square root of 7, and the second leg is the square root of 7, and we don't know the hypotenuse r. So 2 times the square root of 7 squared is 4 times 7. Square root of 7 squared is 7. So that gives us 28 plus 7 is r squared. So r squared is 35, and r is the square root of 35. In 3 through 6, we're using a trigonometric ratio to write an equation and then solve it to find the unknown side or angle measure in exact or calculator ready form. So we have in number 3, a 28-degree angle. C is our opposite side, and 5 is the hypotenuse of that right triangle. So if we have opposite and hypotenuse, we need to use a sine ratio. So sine of 28 degrees is equal to opposite C over hypotenuse 5. Let's multiply both sides by 5, and we get C equals 5 times the sine of 28 degrees, and that's our calculator ready form. In 4, we have a 57-degree angle. W is our adjacent side, and 8 is the opposite side. That implies that we should be using a tangent ratio. Tangent of 57 degrees is equal to the ratio of the opposite side length over the adjacent side length. Let's multiply both sides by W, and then we get W times tangent of 57 degrees is equal to 8, and then from there divide both sides by the tangent of 57 degrees, and W is 8 divided by the tangent of 57 degrees. In 5, we're looking for the unknown angle V, so I have the square root of 19, which in relation to V is the adjacent leg of the right triangle, and 6 is the hypotenuse. We should be using a cosine ratio. Cosine of angle V is equal to the ratio of the adjacent square root of 19 over the hypotenuse 6. If we want to undo cosine in order to find the measure of angle V, the measure of angle V is equal to the inverse cosine of the square root of 19 over 6. In 6 we have angle B, for which 4 is the adjacent leg and 7 is the opposite leg. So we'll be using a tangent ratio. Tangent of angle B is equal to the ratio of opposite to adjacent leg lengths. If we want to undo a tangent to uncover the measure of angle B, the measure of angle B is the inverse tangent of 7/4 in calculator ready form. In 7, we want to find the measure of the smallest angle in a 9/40/41 right triangle. I'm going to draw a picture of that 9/40/41 right triangle, with the smallest side being 9, and try to draw that to scale. The smallest angle, let's call theta, is opposite the smallest side. So if I take the tangent of angle theta, then that would be equal to the ratio of the opposite over the adjacent side lengths. And if we undo the tangent here, then the measure that's represented by theta is equal to the inverse tangent of 9/40. By the way, you can choose a different trig ratio and get 3 different possible equivalent answers that all give you the same number of degrees when entered into a calculator. So all 3 are acceptable, and only one needs to be given. In number 8, we're finding the height of this triangle. It's important to recognize that this triangle itself is not a right triangle, but within the triangle there is a right triangle, so we can use SOHCAHTOA. In relation to the 25-degree angle, we have the ratio of the opposite, h, over the hypotenuse, 8. And so solving for h is 8 times the sine of 25 degrees. In number 9, we have a similar situation. Within this non-right triangle is a right triangle. In relation to the 68-degree angle, h is opposite, 6 is the hypotenuse. So again, we can use a sine ratio. Sine of 68 degrees is equal to the ratio of the opposite to the hypotenuse. Multiplying both sides by 6, h is 6 times the sine of 68 degrees. In 10 through 13, we're sketching an angle in standard position with its associated reference angle, labeling the sides with A, B, and C values, and then finding the other 2 trig ratios. So let's start with the angle itself, which has an initial side on the positive x-axis, and if this angle is between 0 and 90 degrees, then its terminal side will fall somewhere into quadrant 1. So theta is this directed angle right here. And let's draw a reference triangle. The reference triangle has a hypotenuse that is the same as the terminal side. Drop from the endpoint of the terminal side to the nearest x-axis, and that forms a vertical side. The horizontal side is on the x-axis. So tangent of angle theta is 24/7. That is our ratio of opposite to adjacent. That's a 7, 24, 25 Pythagorean triple. And now that we have this picture drawn, we can find the other 2 trig ratios. So the other 2 trig ratios are sine. So sine of angle theta from the diagram is the ratio of opposite to hypotenuse. And cosine of angle theta from the diagram is the ratio of adjacent to hypotenuse. In 11, our angle starts on the positive x-axis, as all angles in standard position do, and then rotates where the terminal side is somewhere in quadrant 2, because the angle itself is between 90 and 180. So that means that terminal side will go in quadrant 2. And now let's draw a reference triangle. The hypotenuse is the terminal side. From the endpoint of the terminal side, find your nearest x-axis, and that's the vertical side. The horizontal side lies on the x-axis. So our angle is right here, but our reference angle is the angle that falls inside the triangle and has a vertex on the at the origin. So sine of theta is 1/2. That's the ratio of opposite to adjacent. That looks like a 30, 60, 90 triangle where the adjacent side would be the square root of 3, but be careful about direction. This, in quadrant 2, the x values are negative, so that horizontal side is negative. From here, we can find the values for the other two trig ratios. So cosine of angle theta is the ratio of the adjacent to the hypotenuse, and tangent of angle theta is the ratio of the opposite to the adjacent. That's 1 over negative square root of 3, which when we rationalize it would be negative square root of 3 over 3. In 12, the angle starts in standard position on the positive x-axis, and our terminal side is somewhere in quadrant 4 since theta lies between 270 and 360 degrees. So, somewhere in quadrant 4, our angle theta is the rotation from that initial side to the terminal side. When we draw our reference triangle, the terminal side becomes the hypotenuse. From its endpoint, find the nearest horizontal axis, and that's our vertical side. Horizontal side lies on the x-axis. So there's our right triangle. Here's the reference angle inside the triangle with a vertex at the origin. Cosine is adjacent over hypotenuse. We'll have to use the Pythagorean theorem to find the missing leg. So the square root of 5 squared plus b squared is equal to 3 squared. That's 5 plus b squared is 9, and that means b squared is 4, so b is plus or minus 2. And since the side is hanging down, or think of it as quadrant 4 has negative y values, that opposite side must be negative. All right, we need to find the sine and tangent ratios. So sine of angle theta is equal to the ratio of the opposite to the hypotenuse, and tangent of angle theta is equal to the ratio of the opposite to the adjacent. Now that one is negative 2 over the square root of 5. That needs to be rationalized, so that's negative 2 times the square root of 5 over 5. Alright, in number 13 we have tangent of theta is equal to 3. You can change that to a fraction, 3 over 1 if you like. So our initial side is on the positive x-axis. This time our angle is between 180 and 270, which means that the terminal side is located somewhere in quadrant 3. So our angle theta is the rotation from the initial side to the terminal side. When we draw the reference triangle, the terminal side becomes the hypotenuse, and from the endpoint of the terminal side, find your nearest x-axis. That's the opposite or vertical side, and then the adjacent or horizontal side is on the x-axis. So tangent is 3 over 1. That's going to have to be negative 3 over negative 1 since our angle is in the third quadrant where x and y are both negative. Now we need to do the Pythagorean theorem, and this negative 3 squared plus negative 1 squared is equal to c squared. So 9 plus 1 is equal to c squared, and c is the square root of 10. So our hypotenuse is the square root of 10. Now we need to find, once we've got the diagram finished, the other two trig ratios. So we need to find the sine and we need to find the cosine of theta. Sine of theta is equal to the ratio of opposite over hypotenuse. That would be negative 3 over the square root of 10, which when rationalized is negative 3 times the square root of 10 over 10. And the cosine of angle theta is negative 1 over the square root of 10, which when rationalized is negative square root of 10 over 10. In 14 through 19, we're drawing each angle in standard position, along with its associated reference triangle. Or, for our quadrantal angles, we're just going to draw the endpoint of the terminal side and use it to find the three trigonometric ratios, indicating that a trigonometric ratio may be undefined. All right, in 14, we're looking at a 210 degree angle. So for a 210 degree angle, we'll start with our initial side and rotate 180 degrees plus an additional 30 degrees. So our 210 degree angle goes from the initial side to the terminal side, but in the reference triangle, the reference angle will be 30 degrees. Remember that our hypotenuse is the terminal side, and if you go from the endpoint of the terminal side to the nearest x-axis, that will form the vertical side, and the horizontal side is on the x-axis. So in a 30, 60, 90 triangle, the opposite side is 1, but since that's hanging down, that's going to be negative. The adjacent side will be the negative square root of 3. It's going to be our larger leg opposite the 60 degree angle, and hypotenuse is 2. From here, we can draw the trig ratios. Sine of 210 is the ratio of the opposite to the reference angle over the hypotenuse. Cosine is the ratio of the adjacent to the reference angle over the hypotenuse. And tangent is the ratio of opposite to adjacent. Opposite to adjacent is -1 over negative square root of 3, which is a positive. And then when we rationalize it, that will be the square root of 3 over 3. In 15, we have a 315 degree angle. So starting from the initial side on the positive x-axis, we can rotate 180, 270 degrees, and then an additional 45 degrees to get to 315. So that's going to be in quadrant 4. So our hypotenuse is the terminal side. From the endpoint of the terminal side, find the nearest x-axis, and that's our vertical side. The horizontal side is on the x-axis. 315 plus 45 gives us a full rotation, so our reference angle is 45. And our sides for a 45, 45 right are legs of 1 and hypotenuse of square root of 2. However, in quadrant 4, the y value is negative, so the opposite side is going to have a negative directed length. Sine of 315 degrees is the ratio of opposite to hypotenuse. That's -1 over the square root of 2. When rationalized, that's negative square root of 2 over 2. Cosine of 315 is the ratio of adjacent to hypotenuse. That's 1 over the square root of 2. When rationalized, that's square root of 2 over 2. And tangent is the ratio of opposite to adjacent. That's going to be -1 over 1, which is -1. In 16, we're looking at a 60 degree angle. Initial side is on the positive x-axis, and rotate 60 degrees from there. And that is, since it's in quadrant 1, will be the same as the reference angle. The terminal side is the hypotenuse of the right triangle. From the endpoint of the terminal side, find your nearest x-axis, and that is the vertical side, and then the horizontal side is on the x-axis. In a 30, 60, 90 opposite, the 60 degree angle is square root of 3. Opposite, the 30 degree angle is 1, or the smaller leg, and the hypotenuse is 2. So sine of 60 degrees is the ratio of opposite to hypotenuse. Cosine is the ratio of adjacent to hypotenuse. And tangent is the ratio of opposite to adjacent. Opposite to adjacent is the square root of 3 over 1, and we never leave something in the form of dividing by 1. The square root of 3 over 1 is the same as the square root of 3 divided by 1, and when we divide by 1, it doesn't change the value of the number being divided. So simplify that to the square root of 3. All right, in 17, we are looking at a 300 degree angle. Initial side is on the positive x-axis. We rotate 180, 270 to get to a 3/4 turn, and 30 degrees more brings us to a 300 degree angle. When you draw the reference triangle, the hypotenuse is the same as the terminal side. From the endpoint of the terminal side, find your nearest x-axis, and as you do, you'll form the vertical side. The horizontal side is on the x-axis. So since 300 and the reference angle make up a full rotation, the reference angle is going to have to be 60. So that's similar to our last exercise where the adjacent side will be 1, the opposite side, negative square root of 3, since in quadrant 4 y values are negative, and the hypotenuse is 2. So sine of 300 is the ratio of opposite to hypotenuse, negative square root of 3 over 2. Cosine is the ratio of adjacent to hypotenuse, that's 1 over 2. And tangent is the ratio of opposite to adjacent, so that's negative 3 divided by negative square root of 3 divided by 1, which is negative square root of 3 in simplified form. In 18, we have a 90-degree angle. Initial side is on the positive x-axis, and if we rotate 90 degrees from there, we'll be on the positive y-axis. Since that's a quadrantal angle, we want to take a different approach, and that is we're going to name the coordinates of this endpoint, and the coordinates of this endpoint are 0, 1. The x value is 0 and the y value is 1. Remember that that's our a and our b values. So a equals the adjacent is equal to 1. B is equal to the opposite, which is equal to 1. I think I said that wrong. A, the adjacent, is 0, and B, the opposite, is 1. And then C, our hypotenuse, is going to be 1. We could use the Pythagorean theorem to find that if we wished. 0 squared plus 1 squared is equal to C squared gives us 0 plus 1 is equal to C squared, and C squared is equal to 1, which gives us a C value of 1 since the hypotenuse is always positive. Alright, from here we're going to find our sine value. Sine is opposite over hypotenuse, that's 1 over 1, which is 1. Cosine is adjacent over hypotenuse, that's 0 over 1, which is 0. And tangent is opposite over adjacent, that's going to be 1 over 0, which is undefined. Technically, we don't say equals undefined, so to better say that, we're just going to change that equal sign to an is. In 19, we have a 0-degree angle, which means there is no rotation, and terminal and initial sides will be the same. The endpoint of that initial or terminal side is 1, 0. So that means that A, our adjacent side, is 1, and B, our opposite side, is 0, and C, our hypotenuse, will be 0. So from here, sine of 0 degrees is the ratio of opposite to hypotenuse, that's 0 over 1, which is 0. Cosine is the ratio of adjacent to hypotenuse, that's 1 over 1, which is 1. And tangent is the ratio of opposite to adjacent, so that's 0 over 1, which is 0. In 20 through 23, we're evaluating each trigonometric expression. So we have a 60-degree angle in number 20. That's a first quadrant angle, so I can sketch that. Our reference and theta are the same value in quadrant 1, so 60-degree angle, and we put in our side lengths for a 30, 60, 90 triangle. And our expression is 1 plus 4 times, and the tangent of 60 degrees is the ratio of opposite to adjacent, that's square root of 3 over 1, which is square root of 3. So this expression is 1 plus 4 times the square root of 3. Those are unlike terms, much the same as 1 plus 4x would be unlike terms, and we wouldn't combine them. In 21, we have a 45-degree angle. That's also a quadrant 1 angle, so I'm going to draw my 45, 45, 90 triangle with legs of 1 and hypotenuse square root of 2. So our expression is equal to 5 times the square root of 2 plus 2 times the cosine of 45. Now the cosine of 45 is the ratio of opposite to hypotenuse. That's 1 over the square root of 2, which is square root of 2 over 2. Now we're going to perform our multiplication. 2 times the square root of 2 over 2 is just the square root of 2. And 5 times the square root of 2 plus 1 times the square root of 2 is 6 times the square root of 2. In 22, we have a 180-degree angle that we're working with. That's a quadrantal angle, so we probably just want to draw the angle and get the endpoint for its terminal side. 180 degrees is a half spin from the positive x-axis, so that means the endpoint is negative 1, 0, and that means that A, our adjacent side, is negative 1, B, our opposite side, is 0, and C, our hypotenuse, is 1. So our expression is 2 minus And the cosine of 180 degrees would be the ratio of opposite to hypotenuse. That's -1/1, which is -1. So 2 minus -1 is 3. In 23, we have a 150-degree angle that we're working with. So our initial side is on the positive x-axis, and we'll rotate into quadrant 2. If that's 150 degrees, when we draw the reference triangle, the hypotenuse will become the is the terminal side and drop from the endpoint of the hypotenuse to the nearest x-axis. That's our vertical side. Horizontal side is on the x-axis. So if the angle is 150 degrees, the reference is the supplement to that 30 degrees. Opposite side will be 1, adjacent -square root of 3, and hypotenuse 2. So our expression is 7 minus 15 times the tangent squared of 150. So we're going to find the tangent and then we're going to square it. The tangent of 150 is the ratio of opposite to adjacent, and I'm not bothering to rationalize that because we're about to square it. So 7 minus 15 times, and the square of -1 over the square root of 3 is 1/3. So now we have 7 minus 15 times 1/3 is 5, and that gives us a final result of 2. For this next section, we're finding all the solutions or values of theta that make each of these trig equations true, but just the values of theta that lie between 0 and 360, inclusive of 0 and not inclusive of 360. So in number 24, we're going to notice that cosine here is positive. Remember, Andrew sells trash cans, Albany State Teacher College, whatever device you like to use there to remember this, means that all trig functions are positive in quadrant 1, so that means cosine will be positive. In quadrant 2, sine is the only positive trig function, and so that means cosine will be negative, so we're not looking there. And then in quadrant 3, only tangent is positive, and finally quadrant 4, cosine is positive. So since cosine is positive square root of 3 over 2, we'll be looking there as well. We're going to get two solutions, two theta values, each of which will terminate in quadrants 1 and 4. So in quadrant 1, we can draw a picture of the angle, and if cosine is the square root of 3 over 2, when we draw the reference triangle, if this is theta, square root of 3 is our adjacent, and 2 is the hypotenuse. That's going to be a 30, 60, 90 triangle, and so opposite the 1 is our theta value. That's going to be a theta of 30 degrees. Our second quadrant that we are looking in is quadrant 4. And for it, we draw our angle. We rotate all the way into the fourth quadrant, making that into a reference triangle. The terminal side is the hypotenuse, and the angle here inside the triangle is the same reference as the one in quadrant 1, because our sides are square root of 3 is the adjacent and hypotenuse is 2. Difference being here that the opposite side will be -1, but the cosine is still positive square root of 3 over 2. In this case, theta is 330 degrees, or 360 minus 30. So our final solution set here is the set that includes 30 degrees and 330 degrees. In 25, ASTC tells us when we are looking for sine to be negative, we will find that in the third and fourth quadrants. So let's make a third quadrant picture. Third quadrant. Our angle rotates from the positive x-axis to a terminal side in the third quadrant. Hypotenuse is the terminal side, and when we draw the reference triangle, sine is -1 half. So opposite is -1, hypotenuse is 2. That's going to give us a adjacent side of -square root of 3. And that's going to be a 30-degree reference. When we're in quadrant 3, the angle theta that goes all the way half turn in an additional 30 will be theta equal to 210. Now let's draw a quadrant 4 picture. And in quadrant 4, we're going to have the exact same reference triangle with a 30-degree angle. Because our opposite side will still be -1 and our hypotenuse 2, this time the adjacent side is positive square root of 3. So this time, you notice that the angle theta and 30 degrees form together 360-degree rotation. So 360 minus 30 is 330. So our two solutions are 210 and 330. In number 26, tangent of theta is equal to -1, ASTC, and we're looking for where tangent is negative. So tangent is negative in quadrants 2 and 4. So let's draw a quadrant 2 picture. And in quadrant 2, our terminal side is such that tangent is -1. We can make that into a fraction, -1 over 1. That's the ratio of opposite to adjacent. So our opposite side could be -1 and our adjacent could be 1. Hold on, that doesn't look right. The y value has to be positive and the x value has to be negative. So we can switch from numerator to denominator as appropriate. Okay, so that's going to be a 45-45 right triangle, and our missing side there is the square root of 2. So if that's a 45-degree angle, that's our reference. The angle theta is equal to 180 minus 45, which is 135. All right, let's draw a quadrant 4 picture. In quadrant 4, we're going to have the exact same reference triangle with a 45-45 right. This time our opposite side is -1 and adjacent is +1. And our angle theta and 45 together make a 360-degree angle. So theta is 360 minus 45, which is 315. So our total solution set here is 135 and 315 are possible values for theta. In 27, tangent squared of theta is equal to 3. So we're going to begin by unsquaring or undoing the square. Remember that when we have a square that's equal to a positive number, there are two real solutions. So positive and negative square root of 3. We can make that into a fraction, square root of 3 over 1. So we are looking for an angle that has a tangent of either positive square root of 3 or negative square root of 3. This is going to increase our possibilities, and we'll look for a solution in every quadrant. So let's draw quadrant 1 picture. So in quadrant 1, reference triangle, and tangent is the ratio of opposite to adjacent. That's going to be a 60-degree reference angle, so that'll give us a theta of 60. Now let's look at quadrant 2. We're going to draw the exact same reference triangle, but just over reflected across into quadrant 2, because our our opposite over adjacent is negative square root of 3 now, and hypotenuse is 2, but that doesn't matter. Still a 60-degree reference angle, and our angle theta this time is the supplement of that, so our theta is 180 minus 60, or 120. Now let's look at quadrant 3. quadrant 3. We're going to draw the exact same reference triangle. So it'll have a 60-degree angle because now our ratio of opposite to adjacent will be positive square root of 3, negative square root of 3 over negative 1. And that's going to still give us a 60-degree reference angle. The actual angle here is that half turn plus another 60 degrees. So 180 plus 60 degrees is 240. And then for our last angle, that would be in quadrant 4. The exact same reference triangle, because now we have the ratio of opposite to adjacent is negative square root of 3 over 1. And this time our angle theta and 60 degrees make up a full rotation. So theta is 360 minus 60 is 300. So our final solution set here is the solution set that includes 4 solutions, 60, 120, 240, and 300. Remember the plus or minus is what's going to increase the number of solutions.